Welcome. Let's take a look at some confidence intervals for estimating unknown population proportions. All right, so number one, the Department of Veterans Affairs is under fire for slow processing of veterans' claims. A journalist wants to determine what proportion of claims have been open for more than 1 year and decides to investigate. In a random sample of 60 claims, the journalist finds there were 27 that had been opened for more than a year. Find a 90% confidence interval estimate for the proportion of all claims. So this will be our population proportion that have been open for more than a year. All right, so as usual here, we're trying to use a sample to draw a conclusion about a population. All right, so let's just put some symbols here. So we are estimating, so the symbol for the unknown population proportion is just a lowercase p. So that's our population proportion. And to construct the confidence intervals when we are estimating proportions, it's called a one proportion Z interval. All right, so let's write down the other given values here and start with the 60. So that was a random sample of 60 claims. So that's our sample size, N. And the number that were open for more than a year, so that would be the number of successes in the sample, that's our X. All right, and then it says, find the best point estimate for P. So the best point estimate for the population proportion is the sample proportion, and I'll even write it in English here first. So the best point estimate is the sample proportion, and the symbol is P hat. And P hat, that proportion, you just take your X and divide it by N. So in our case, 27 out of 60 claims. Okay, so let me enter that on the calculator here. 27 divided by 60. So we don't even have to round that. That's exactly 0.45. And just so I can speak it here, I'm going to switch that to percent. So in the sample, 45% of the 60 claims sampled had been open for more than a year. All right, so that's called our best point estimate for the population proportion. And now let's turn this into a confidence interval. So on our calculators, we're going to go to our stat button, head over to tests, and we're going to go down to our one proportion Z, I'm sorry, not Z test, keep going, our one proportion, there we go, one proportion Z interval. Just so you know, these things at the top, tests, are the subject of the next chapter. Right now we're doing confidence intervals. So one proportion Z interval. So I'll hit enter there. And then they want X first. That was 27 of the claims. And then N next out of the 60. Confidence level 90%, so 0.9. And then calculate. And now I'm going to be rounding to 3 decimal places. So the lower limit would be 0.344. So 0.344. And then we're going to always write here, it says in this form. So there's our lower limit and then less than. And then the parameter that we're estimating is the population proportion. So we believe with 90% confidence that the population proportion is between 0.344 and then 0.556. All right, and then when we write the sentence summary, we will express those proportions in percent form like we would normally speak. So based on a random sample of, so this was 60 VA claims. we estimate with 90% confidence that the true proportion, so true, a substitute there for the word population, so we use those interchangeably. So the true population proportion of all claims that have been open for more than a year, we believe is between, so in percent form, that would be 34.4% of them and 55.6%. Okay, let's try another one. All right, so number 2. Radio station WKRP claims they hold 18% of the market. Suppose a random sample of 400 radio listeners revealed that 62 listen to WKRP. Find a 95% confidence interval for the proportion of all radio listeners who listen to WKRP. Okay, so let's start with our study here. So N, we did a random sample of 400 listeners. X, the number that listen to WKRP, 62. And we're doing a 95% confidence interval, just making a note for myself there. And we're going to find the sample proportion. So based on this particular study, the sample proportion p hat, it's called our best point estimate. It's just X over N. So 62 out of the 400 radio listeners said they listened to the station. We'll divide there. And that is 0.155. I'm just going to write it as a percent so we can speak it. So in this study, 15.5% of radio listeners listen to the station. And then we're going to turn that into a confidence interval. So let's go to, again, stat tests and one proportion, but go to your intervals, one proportion Z interval. And then X first, 62, N next, 400. Confidence level this time, 95%, and calculate. And I didn't point out last time, but I see there my p hat on the screen, 0.155 that we calculated. And then let's round to 3 decimal places. So the lower limit there would be 0.120. Being careful with your rounding, and then less than P, the population proportion that we're estimating, and then 3 decimal places for the upper limit will be 0.190. All right, always important to remember the symbols here. So just really emphasizing that this isn't mu anymore. It's not population mean we're estimating now. These are population proportions. All right, and p hat is your sample proportion. Okay, now I do want to write this one in the second form that we had discussed. So let's go ahead and find the margin of error. So to find the margin of error, we can take the upper limit minus the lower limit and divide by 2. So let's do that. So the upper limit, 0.190, minus the lower limit, 0.120, divide that by 2. All right, we want to make sure we get order of operations correct. So we do our numerator. Hit enter there, that's the numerator, and then divide by 2. And that's 0.035, or as a percent there, 3.5%. Okay, so we could have also, rather than writing it in that form, we could have said that we believe the proportion, population proportion is, so our point estimate was 0.155. I'll write this in decimal, 0.155. And then plus or minus our margin of error in decimal, 0.035. And in percent, So 15.5% plus or minus 3.5%. Okay, so we always have a choice of which form to write our confidence interval. And when I write the sentence here, since it says between, we're going to be writing it in that form. So based on a random sample of, this was 400 radio listeners. We estimate with 95% confidence that the true proportion of radio listeners, all radio listeners who listen to WKRP, we believe it's somewhere between, so as a percent, 12.0% and 19.0%. All right, so whether it was in decimal or percent form, notice that I'm writing that 0 in the third position here, rather than leaving it off, because it lets people know that we are rounding. Our accuracy is to 3 decimal places, and then our accuracy there is 1/10 of a percent. All right, so let me draw a picture of this confidence interval. So the lower limit is 0.12. Actually, let me draw that on the line. So that's 0.12 lower limit, upper limit 0.19. I'll put in my p hat, my point estimate, 0.155. So there's my p hat. And that margin of error, then that distance from your p hat to the upper and lower limit is 0.035. All right, so that's your margin of error. There's your p hat. So if you subtract, you'll get to your lower limit. Take p hat and add your margin of error, you get to your upper limit. All right, so those are the pieces of a confidence interval. So we think that the true proportion P is somewhere in there. We want to see if that confidence interval contradicts WKRP's claim. So they claimed that they hold 18% of the market. So 18% would be equivalent to 0.18. So this is their claim. So WKRP claims that P is 0.18. So our confidence interval is not contradicting them, because their claim is contained in our interval. So the confidence interval does not contradict WKRP's claim that they hold 18% of the market, because 18% falls inside of our confidence interval. All right. So there are 2 examples for you for estimating unknown population proportions using p hat sample proportion, which is called your best point estimate.